Hi guys, this is Dan Bentley from Section D, and I'm just going to make a quick video, hopefully quick, of questions 2 and 6 from the test. So make sure you're checking the mark scheme for all of the feedback on the questions, but I'll just go into a couple details on these two questions in particular. Okay, let's see here. Yeah, question 2. We had we to find the limit, okay? And this is, hopefully you recognize this, especially with it being irrational. It's probably going to be L'Hopital's rule, okay? So we're going to look at that. We're going to take a quick look. We're going to kind of look at what happens if we subbed in a 0 and we get 0 over 0, okay, in indeterminate form. So we're going to do L'Hopital's. We're going to take the first derivative of both the top and the bottom, okay? Remember, we're not using the quotient rule. We're just actually taking two separate derivatives of the numerator and the denominator. Okay, it gives me secant squared x and 1 plus 2x, and hopefully now I'm going to try and see if I can take the limit of this as let it go to 0, and that numerator, that's 1 over cosine, right? So subbing in 0 there would give me 1 over 1, and on the bottom, if we subbed in 0, we would get 1. So I could say the limit is going, as x approaches 0, is going to 1. Okay? The next one was the same idea, but just a little more complicated, right? So in this one, we take a quick look. If we were to sub in 1, because this time the limit is going to 1, not 0, we would get an indeterminate form, 0 over 0. So what we're going to do is we're going to do L'Hopital's, take the derivative of the top, and take the derivative of the bottom. So numerator and denominator. We've got a little product rule going on here. Okay, so that's product rule for this part, and then a chain rule on the bottom, right? So it's the derivative of sine pi x over 2, and then don't forget to do the derivative of what's inside. Okay, so those should be your two derivatives, and then you might want to, well, I'm just going to tidy it up really quick and just clean that up. Now if I were to sub in 1, I again get 0 over 0, another indeterminate form. So L'Hopital says take another derivative of both the numerator and the denominator. So here we go. If I take this derivative, again I have a product rule, and then on the bottom I now have plus sign. Don't forget to do the chain rule. So that gives me pi squared over 4 as a constant out front. Okay. If I clean this guy up, let me clean up that numerator a little bit, simplify it. Okay. Now at this point I'm going to actually let the limit go to 1 and see what happens, and I get 4 on the numerator and then pi squared over 4 as my denominator, and I can kind of flip that and get 16, so 16 over pi squared, as that's my limit as x approaches 1. Okay? All right, moving on to question 6, we have a big differential equation here. We're asked to solve it. So remember our Vx substitution, and then we also do the product rule on Vx, and we use dy dx equals v plus x d, that should be dv, I'll fix that in a minute, dv dx. So I'm going to try this. Let's just see what happens. Let's see if I plug it in. There's a little sort of trick to this one that comes out at the end, where a lot of the students I marked didn't catch the trick, so they kind of the last part of it. But most of the papers I looked at, you start off really well. So the first thing I'm going to do is put the x squared over on the other side. Okay, so I've got dy dx by itself, and now I'm going to use the substitution on my left side, and then I'm going to also use my substitution, my Vx, on the right side. I just kind of chunked up that denominator, so I have 3 different terms there. I found that just a little easier to look at. Then if I do that, I'm just going to clean up this side. I've got a lot of canceling out to do, and that really slimmed it down a lot. Now if I take a v off both sides, that's just plus v, plus should be v squared plus 2v. Just a minute, let me catch that. Hang on, I'll fix that in a second. So if I do that, now what I'm going to do is I'm going to, hold on a minute. Okay, so now at this time I'm going to kind of switch sides here, bring my x over to one side and bring my sort of my terms in v over to the other side, so that I can integrate both sides with respect to x. So here I go. I integrate both sides with respect to x. Now the right side here is pretty straightforward. But here's where the tricky part comes. So how do we integrate this? And it is tricky. I didn't see it at first. But if you think about it, that quadratic can be written as a perfect square quadratic. Okay, v plus, there's my plus, there we go, v squared plus 2v plus 1 plus 1. And then that can be written as v plus 1 squared plus 1. And hopefully you recognize the reason I'm doing that. This is one of those sort of ace in the hole that pops up here and there. If you recognize that rational I have on the left as the derivative of arcsine, so when you go backwards and you take the integral, well, let's do it on the next page. If I take the integral of that, that leaves me with, sorry, I said arcsine, I meant arctan, of v plus 1, and then I've got my natural log plus c on this side. Okay, we've been given a condition when x equals 1, y equals negative 1. I can back sub in and get it in terms of y and x now. Don't need my v anymore. It served its purpose for me. Okay, so if I do this, I'm subbing in, and I want to find a value for c, so that's going to be arctan of 0 equals natural log of 1, which is 0, plus c, and then I have c equals 0. Okay, so that's my constant, 0. I could finish this off. I think they wanted it in y equals form, I believe, on this question. So as I work that out, I'm going to back sub, and my last thing here, I'm going to subtract 1 from both sides, and I'm also going to multiply both sides by x. Okay, so there's your final answer on that one. So it was a big, long question with that little arctan sort of trick in there, and if you missed that arctan, I think this question got pretty ugly at the end. Okay, so, well, guys, that's all I have on those two questions, but please take a look at the mark scheme and work through those other questions. There's lots of little details to pay attention to. And, well, guys, we're almost there. We're just about done the course, and you guys are preparing for the exam, so you've come a long way, and keep up the great work. Okay, take care.